So good morning, students. Today, now we are going to we discuss about the stresses in inclined plane, and it's an important one. And because many times the object have subjected to the inclined loading, and we need to be find out the stresses on that inclined plane, because the impact of that is more than when the when you calculate the stress on perpendicular plane. So we can see, and this is a inclined plane, you can see here, and this is this one. And like you can see, my dear, so there is two cases. First one is this: if I incline, this is inclined plane AB. So inclined plane AB, we are going to be find out the magnitude of the stress. One is the normal stress, another is the shear stress on this plane AB. Okay, but actual loading is in the plane AC and BC. So suppose you have any object, but two type of loading is there. One is the X toward the X direction, another is the Y direction. Then they ask you calculate that stresses magnitude on inclined plane. So you have to be use this procedure, or what outcome we are going to be get, so we can directly use that one. So assume that here, consider a small element a b c. We have taken a b c, a small element. Thickness is t. This thickness is t. So with the BC and AC perpendicular to them, it means this one is the perpendicular to each other. This is a 90-degree. Okay, and AB makes an angle theta with the plane BC. So this BC plane BC, and it's make AB angle theta. This is theta, and let's determine the normal and shear stress in the inclined plane AB. So you can see here, this we have to be find out this one. So we are assume that the direction of normal stress in the outward, and here the shear stress in this word. And you might be know that what is the normal stress and the shear stress. Normal stress, that the stress which is acting at the perpendicular to the surface. So because this is a surface and this is acting on perpendicular on that, so this is called a normal one. And which is acting tangential to that surface, this surface, so that's only this is called the tangential or shear stress. Tangential stress or shear stress, both are the same thing. So अब आप देख लीजिए, you can try to be understand. So in this direction, I stress sigma x is produced. Sigma x stress is produced here, and here the sigma y stress is produced in this y direction. Sigma y and sigma x. Sigma x is there. So, because this stress is produced due to the external loading, so definitely the load Px is applied on this plane. So here the stress is produced sigma x because of this force Px. And likewise here, this sigma y is produced because of this load or force Py here. So you can see, easily you can understand. So this load you are applied. Now you need to be calculate the stresses, magnitude of the stress here. So you have to be take a perpendicular one is the resolution of this force. You can see, one is the parallel to this plane, and one is the perpendicular to this plane AB. You can easily understand. So you can see this is a perpendicular one to this plane, and this is a parallel to this plane AB. So just resolve it. So this and this, and you can see that because this is parallel to the BC, this PY, and this angle must be theta. So this become PX cos theta, and this becomes PX cos sin theta. Okay, you know all that. How to resolve the force? It is a very we know that in our 10th 12th and all that we have studied how to resolve the force. So I think it you know all that. So similarly, this is what happened here in this plane. If you're talking about this Py, and if you resolve one component and that's perpendicular to the plane AB, and one is the parallel to the plane AB, so there is two component also. and you can easily you can say that this will be this time this make the angle theta. Okay, if you are able to be resolve, you can see that simply. So this angle must be a theta. So once you know that this is a theta, so it's become py cos theta, and that's become py sin theta. I think you are now all are understood. So why this blue and arrow and red arrow I have taken? Because the stresses is produced due to the internal force. So this is externally applied force, and internal applied force, yeah, no, the produced force, it is due to the external applied force. So this is showing this one is internally, which is opposite to the external one, and that's why the stresses is produced. So this is showing the internal force of same magnitude. You see that. So ठीक है, आपको अब समझ में आया होगा, no problem. So what we are going to be do? So we are going to be one directional force we are going to plus minus add or minus depend on the sign, and this direction of force we are going to be accumulate sum of this direction force and sum of this direction force, and with their sign. So you are understood. So now you can see that what we have done. So normal force acting on plane, you can see normal force acting on BC is this and AC is this. Okay, so normal force acting on AC. So see, AC is this. So how can find? We have Px ACT into sigma x. AC is this. This is AC. T is the thickness, so it's become area of this. So this area you can calculate by AC and multiply this thickness, so you will get the area of this. So Px is equal to ACT into sigma x, and we can say अगर हमारे पास स्ट्रेस है, सो उससे हम फोर्स कैसे निकाल सकते हैं, कि हमको पता है कि सिग्मा मतलब स्ट्रेस इज इक्वल टू force upon area where the force acting. So this force is acting this plane, in this plane, so we need to be calculate area of this plane, and simply you can calculate by this AC means this distance, this length and this thickness. You will get the area of that and stress it produces in that plane. You can find the value of load or force. Similarly, normal force acting on plane BC, this plane BC. So what happened? BC into T into sigma y, BC into T into sigma y. Then normal resisting force on plane AB and shear resisting force on the plane AB. Resisting force opposite actual generated force के वो opposite होता है. So here it's shown in the color of red. You see that. Okay, so let's see the normal resisting force on plane AB. AB means like this AB. So see my dear, so this resisting force is acting downward, and this to this direction and this direction. So it means you can say write Px sin theta plus Py cos theta is equal to Pn. Pn मतलब normal force acting on the plane AB. So Px sin theta plus Py cos theta. So now shear resisting force on plane AB, PT for tangential, T stand for tangential. So here you can see, say my dear, so shear resisting force PT is equal to Py. You have to understand, see this diagram. So this is moving the one. So this one Px cos theta, and this or this one in the same direction. So this Px cos theta, and this is opposite one. So if you आप उसको ऐड करेंगे, बैलेंस करेंगे, बैलेंस ऑफ द फोर्स या इक्विलिब्रियम ऑफ द फोर्स, यू कैन अप्लाई द लॉ ऑफ इक्विलिब्रियम. So in this case, so it's become Pt Py sin theta minus Px cos theta. Okay, so now if sigma theta tau theta is the normal and shear stress double on inclined plane, So that's simple. This you have. this is this is stand for normal force. अब वैल्यू रख दो इसमें, पी एन की जगह यू कैन पुट द वैल्यू ऑफ व्हाट इज the sigma. You can see that the sigma theta is there. Sigma theta, which plane AB, thickness T, so it becomes sigma theta AB into T, and you put the value of sigma Y here. And okay, so this is become like this here. So sigma px, in place of px you put the ac into t, sigma x and sine theta plus sigma y bc t cos theta. Just I put the value of px and py from this, from here. This is the step. And this AB you divide the in both term. So now it's become AC upon AB and BC upon AB, and this sigma x TT cancel हो जाएगा. So it's become sigma x AC upon AB sin theta plus sigma y BC upon AB cos theta. So AC upon AB, AC upon AB will be, here you can say AC upon AB. If it is a right angle triangle, so it is called as a sine theta. So that's why it's written sine square theta. And BC upon AB, you can see BC upon AB, base upon hypotenuse, that is called cos. So it's become cos square theta. And sine square theta we can write is 1 minus cos 2 theta by 2, and cos square theta ko we can write as 1 plus cos 2 theta by 2, and we just solve this. So sigma theta is equal to sigma x plus sigma y minus sigma x by 2. This is equation number 1. Now you can remember this equation. Whenever asked the calculate, you find out the stresses on the inclined plane, use this formula directly, where sigma x sigma y might be given the question otherwise in term of force. So you can easily able to calculate, just put the value and you will get the value of normal stress on the inclined plane. And every time the value of theta you have to measure this direction in like this. So in this arrangement, for this arrangement you can use direct this equation. Similarly, what I am going to next, we are going to be find the shear stress on inclined plane AB. So in this formula, I just going to be put these two values. So you are able to be calculate like this. So all the sigma tau theta AB AC and like are put the all value and just divide by AB in the both term, and sigma y t is cancel out. So it's become, so BC upon AB you have already seen it is called cos theta, and AC upon AB is called sin theta. So it's becomes sin, you can directly write this. You just take the common of these two, so it's become sigma y minus sigma x, and here it's become sine theta cos theta, and sine theta cos theta you can write one sine 2 theta by 2. So this by 2 come here, so it's new for this formula become sigma y minus sigma x by 2 sine 2 theta. So these two relation you have to be remembered to getting to solving the normal stress and shear stress on inclined plane. Why it is like tau theta means it is shear stress on inclined. Inclined we can represent by the angle, that's why theta is coming, and that normal stress called sigma theta means the stress is on the inclined plane. So these two relations you have to be remembered to in future to solve the problem uh, in based on this particular the stresses when you going to find the stresses on the inclined plane. So it is easier one. So now the stresses in inclined plane, and the consider a small element A, B, C of thickness T with plane BC and AC. That is second one. That the first one is okay. It's fine. It's finished, because in this there is only we are consider the normal stresses on in this plane, perpendicular plane. But here you have to be considered. Look here, you have to be considered there, and the shear force is also acting, or tangential force also acting here. So we can say tangential force acting. So because of tangential force, as tangential stress is produced in this plane of plane axy or this plane. Okay. So plane BC having one force, plane AB having one tangential force. You can see by the here. So all the arrangement is previous, but one thing is added here, that is this, and this part of this is the tangential one. This you can see, this is added. Okay, so we are going to be adopt the same procedure, nothing else. We are going to be adopt the same procedure. So let's see. So what new thing is that, but it's very simple. Look, this sigma, this is produced by this px. When you apply this normal force, so this is produced. Okay, and this shear stress, this one which is acting on plane BC, this is produced because of a tangential force acting on this plane BC. So I am telling here that is Fx. आप इसको for better understanding you can write here, you can just for bracket, this is Fx. Fx. So this is produced by this force Fx which is acting. So this tangential force is and here you can say Fy. Why Fy I am telling you, because it is acting by y direction. This is acting toward the x direction. So now this relation become px plus Fy, two force, the same direction. Now the same procedure, this is theta and resolve two part component, and similarly here it's become py is side normal force directly acting, that is py, and this is Fy resolve two component, P by F by sine theta and P by F by cos theta, and you adopt the same procedure. Once you are understood how to resolve these forces, so the things are so easy. You look, all these are the same thing. We are calculating the normal force acting on the plane BC, BC, BC. You can see BC is this y1, this one. So how you can say Py is equal to normal force, मतलब sigma y से relation है, so sigma y BC into T, and the shear force acting on plane BC Fx. Fx मतलब टूवर्ड x की तरफ एक्ट कर रहा है, लेकिन एक्ट कर रहा है क्या BC पे. So we can say T BC T tau BC into T. Now the normal force acting on plane AC, you can see this is a plane AC. Okay, this is AC plane. The normal force, how can calculate the stress sigma x into the area of this, area is AC into the thickness of this, AC into T. So sigma x, you can look the sigma x AC into T. Similarly, the shear force on plane AC, this shear force on plane AC is this one, AC, the area of this, and force is Fy. So it's become, you can see the in the tau into AC into T. So you can calculate. Now the total horizontal force PH, PX plus Fx, and total vertical force, total horizontal and total vertical force you can calculate. And now the normal resisting force on plane AB and tangential force acting on the plane AB, the same concept we have adopted is that just use the equilibrium of the force concept. Okay, so same directional force, same direction matlab same plane which is acting on the same plane in the same axis, you add on it. Either it will be add on basis of its direction, which is going to be, all left side is positive, right side is negative, whatever you want, you can take it and you will get this value. So all the normal force, and you can see that the AB, which force is on the normal resisting force. So you can see here this one. So this So this is acting means these are going to be add on. This py fy cos theta and py fy sin theta is going to be add on. Okay. So आप ये देख लो. So similarly we have on put out all values and सारी value हमने वही procedure we have applied. Respective value of py, fy, px, fx की we have हमने यहाँ रख दी है और उसको वी जस्ट सॉल्व दैट. जैसे हमने इसको सॉल्व किया तो वी हैव गॉट फर्स्ट रिलेशन इज सिग्मा एक्स प्लस सिग्मा वाई अपॉन टू. सब सॉल्व करने के बाद ये सिंपल मैथमेटिक्स है यहाँ पर. मेनली यू नीड टू बी अंडरस्टैंड दिस वन ओनली. सो होप यू आर अंडरस्टूड and you can write the all values. I have already given to you the notes of this unit, so you can once you revise from there. If your if still you have, you can ask, no problem. The same procedure is there. You this in this equation you this in this equation once maybe I put the, all the value of px, pfx and py and fy, and once in this equation they put the, all the value and solve it. So final expression is the sigma x sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta plus tau sin 2 theta. This is simple in mathematics. You can solve it. And that similarly this equation you put all the respective value and you will get that sigma y minus sigma x by 2 and sin 2 theta. In previous one, in the first case you have obtained this one only, and this case this is add on minus of tau cos 2 theta, and this equation this term is plus tau sin 2 theta, it's add on. So there is two condition. One, the plane which having which when acting only the normal force, and second one is the when the normal and tangential force both acting on the plane, then you can able to be get, you are able to find the normal and shear or tangential stress on the inclined plane. So ये part, ये these equation you have to be remember, and you must try to be solve the numerical based on that. Already it is on your that um, question, that um, notes provided by me on that. You can see that if you are able to solve, that you will see, and that you apply this simple formula and try to be remember this process only, how to resolve the forces and how it's become px plus px plus fy, and how it's become py plus fy. So if you understood this part, so you are easily able to resolve, find this. I think it doesn't matter, simple mathematics concept. So this is about